Hi, ACST1052 students. This is Doug Fletcher with one of a couple of videos that I'm doing to tidy up a few loose ends regarding dynamic arrays in Excel. Here I want to revisit one of the problems, the earlier problem demos in Excel. So we're looking at demo number 3, the Euler problem, where we're trying to find the sum of all integers which are multiples of 3 or 5 in the range of integers from 1 to 999. Now, just so we can see what's at both ends of our long sequence here, I'm going to split the screen, and I want to split it around about there, row 17. I go to the View tab and go to the split icon here, and this means that I can scroll the bottom half of the screen down to the bottom of this long sequence. And so you can see all this sequence is controlled by the one sequence command, 999 rows in one column, and then we've just used the default values for start and step, which are each 1. So we've got 999 rows, we're starting from 1, we're stepping by 1, and so that gives us integers from 1 to 999. Now, our problem here was to find the sum of integers which are multiples of 3 or 5, and we did the finding multiples. We took a number, and then we want to take for the dynamic arrays, we had to add the hash character, and that gives us the whole list all at once, and the divisor there will be 3, that's in the cell B9, and I'm going to want to copy this sideways, and so we'll take, we'll fix this reference to column A, so $A10 there. All right, now that gives us the modulus, but of course we want to know that it's divisible by 3, and that will be where the modulus equals 0. And this will give us false or true, because this is a logical statement. Either the modulus is 0 or it isn't. And so if we filter on this just for the true values, we'll find that we have all the multiples of 3, 3, 6, 9, 12, 15, etc., right through to 993, 996, and 999. So just going back to having all the rows visible, and having fixed the address for the integer sequence, we can just copy this across, and the same will work now referring to the 5 in C9, and if we filter this list for the true values, we will have multiples of 5. Okay, so that's what we want to see there, and that's all working very nicely. And then you would hope that we can simply use our logical functions that we're used to, and we want an or in this case, and we want them to be divisible by 3 or 5. And so we'd just take B10 with all that data, and then we'd take C10 with all the data array under that, and close the expression and hit enter, and all we get is a single value, which in fact seems to be false just at that point. All right, I'm not sure where that is. It says true, but that true value is actually false because it's not correct for the number 1, and I'm not quite sure exactly where that's coming from. So this is obviously a fail in terms of the use of the OR function. Now, this gives us a bit of a problem. We'd really like this to work and produce a whole list that does a element by element OR operation on pairs of elements from those two arrays. Now, we could fudge this using a little bit of arithmetic or something, but really the easiest way to do this is to go to some other functions which are like the logical functions and OR, but they put the word bit on the front, BIT. And as you can see in this little list, These are for general bit operations. So there's a bit and, there's a bit left shift, there's a bit or, there's a bit right shift, and there's a bit XOR. Now, don't worry about the other ones. We're simply replacing the and or functions. And so it's bit and bit or that we're interested in. And bit or in particular is what we're taking here. We didn't want that to say or there, we just wanted to say bit or for the same thing. And if we hit enter there, we'll get what we want. Slightly surprising perhaps that this, rather than using false and true, uses 0 and 1, but that's really no problem at all for anything that we're doing in terms of calculation. And we can see that this is presenting correct values, so false and false, or neither of those is true, so it gets 0. Similarly there, then 3, we get 1 true there, so that's a 1. For 4, they're both false. For 5, we're 1 false, 1 true, and so on. And if we do a filter just to get the 1 values there, then we find the ones that we expect. 3, 5, 6, 9, 10, 12, 15 is there, 18, etc. Okay, so that's behaving quite nicely. So that's working really well, and we really don't need to do any more beyond that. Okay, so just to remove the filter on that, we don't really need that next column that's sitting there at the moment, so I'm just going to get rid of that and shift things left. And then we can calculate our result. And so all we need to do is to take the product of the number array and the logical array here, and that's going to give us the numbers that we want to actually sum. So if the number is not divisible by 3 or 5, we get a 0. If it is divisible by 3 or 5, we get the number, and then we can sum that to get our result. So I've left the result in the spreadsheet. 233,168 is the correct value, and we could go here and type in E10 with the hash and get all those numbers, and we get 233,168. And so this produces what we were after with a dynamic array approach. We simply have formulae in the top cell in each of those columns, and that can give us our result. Okay, so that's fairly straightforward. We can, of course, compress this a little bit. All right, so rather than doing the sum there, we can do this in a couple of ways. We could have we could do a sum product of the logical array and the numerical array, which would produce the same result. We could build in the logical result in terms of explicit formulae. So we're doing, this is taking our BITOR function, and we're doing mod of the integers in base 3, whether that is 0, and also mod of the same integers in base 5, and whether that is 0. And we're taking the product of that and A10, and that should produce the same result. And so now we're not actually using these columns here at all. We're doing the all the logical stuff within the calculation. And you may then ask, well, look, we've got A10 mentioned 3 times in here. wouldn't there be a still more efficient way to do this so we can do the whole thing in a single cell without even generating the sequence? And we can actually do that, and I will just show you how to do that. So let's keep this text here because that's going to be actually helpful. And I'm going to copy that. And then I'm going to do another formula over here. I'm going to leave us a few lines because we're going to spread this over a few lines. Now, what we need is a way of writing the formula so we can generate our sequence, store it, and then use it in our calculations. And that's what this let function does. So I'm going to call our series of integers n. And this will be simply the sequence, if I can spell that correctly. This will be the sequence, and it's exactly the same sequence that we have in cell A10. So sequence to 999 rows, one column using the default values. Now, the way in which the let function works, as you can see down here, you use a name and then you give it a value. And you can keep going in this way. You can then do a calculation, which would be the result, or you can do another name followed by another calculation. And then again, you can give a final calculation, or you can do another name and another calculation. Okay, so that's our first one. And then we could say, if we want to say, it all depends how you want to do this, all right? So you could say divisible by 3. Now, you have to be careful. Is this going to be like the like an address for a cell? Now, let's just be a little bit careful with this. I'm going to do mod n3 equals 0. Okay, now that should be fine, but is this going to actually give us a result? Let's see. So I'm going to put div3 in here, and that's just going to use the result that's been calculated. Let's see if that works. Okay, now we have a problem. And what actually happens here is I think Excel's treating div3 as a cell address. Right, so I want to I'm not sure if I can use a dot there. Let's see. No, it doesn't like that. Let's just call it div. Right, we can do that, and we're getting our big long list of divisible by 3 values in there. So let's see, if we were putting in div3 here, what would happen? It would go to cell address div, or this column div, and row 3. So that's a cell address, and we're not allowed to use that. Okay, so that's the problem with that one. So we might need to use something a bit more long-winded. Okay, so if we called it div by 3, then that's probably going to work. Yeah, all right. So then it'll be fairly obvious what we do for the next one. We're going to have div by 5, mod n base 5. When that modulus equals 0, then it's divisible by 5. And then we might as well go to the formula for our result here. Okay, so if we use our sum product, then we're going to have see the div bys are turning up in the little list here. So I'm going to have div by 3 and then div by 5, and then we're going to apply that to the sequence of integers. Now just note what's happened. I've defined the sequence of integers up here. I've called it n, and then I've used it once, twice, and 3 times. All right, and all that without writing it out to the spreadsheet anywhere. So this is saving toing and froing from writing things out in hundreds of cells in the spreadsheet, and it's doing the whole calculation all within one formula, and that'll produce the correct result there. So this let function is like a wrapper around a more complex calculation. You can define an intermediate result or ingredients in later calculation, and then you can refer to it. You just have to watch out that the name you give to something could not be mistaken for a cell address in an Excel worksheet. But other than that, this provides a very handy way to handle more complex calculations. You can put things on separate lines. You can put a little bit of spacing in there to make it a bit clearer as to what's going on. So this is actually quite a useful thing to do. One other thing just to note here is that you might have another variable name, say res for result, and then you put that on its own line. And the reason you might do this is going to produce exactly the same result there, is if you were trying to debug this, then you can replace the last bit by any of those earlier quantities just to check that what you're getting there is correct. All right, or if you wanted to see whether you've got the div by 5 going correctly, you can see whether that's going correctly. And then when you're happy with things, you go for the actual result. Okay, very useful thing. We've worked out how to do logical operations on logical vectors, and we've got a new way of doing more complicated calculations involving repeated use of a stored result. Very handy stuff. Okay, that's it for this video.